I'm Carolina, and my role in this team is to take care of the mechanics and electronics of the robots.
My name is Julio.
Hi, I am João Pedro, and I am the Raspberry Pi programmer of the team.
Hi, my name is Enzo, and I am part of the Defenders team from Colégio Objetivo, from São Paulo, Brazil.
In this project, we have decided to use not only Lego, but also all the open source resources available to us. This made our robots more flexible to change due to new challenges, plus the advantage of using Arduino shields, which helps our coding development. We are also using a Raspberry Pi responsible for the intelligence of our robots. The robot's base is mainly built with Lego pieces, developed many 3D printed structures in order of having an optimized improvement in its constructors. These 3D structures were printed in PLA through the 3D printer located in our school, where we have developed our projects with the aid of different softwares and professors to attack the sensors, actors, and other electric components to the rest of the robot. The 3D printer structures have parts compatible with Lego and with some screws. To accomplish its functions in the track, including the mapping, it's essential that the robot identifies the main walls. To do so, we use 8 laser sensors able to measure distance with high precision. The robot also has a color sensor made in the school from a small circuitry board, and its positions on it. The identification of temperature measurements is made by 4 temperature sensors with sensors on one of the robot side. Another actor used in this project is the Dynamics AF12A. We use 4 of them for the robot's locomotion. We have developed 2 printed circuit boards using the website EasyEDA to make the electronics more trustable and easy to handle. The different PCBs are for different microcontrollers and their necessities connectors. Because these PCBs are handmade from scratch, some configured patterns are different from those found in industrial made boards. For instance, our signal traces are thicker and signal layered. The robot was built using a ribbon structure, an Arduino Mega, and a Raspberry Pi, which one has a specific functionality in the robot that is defined based on the advance of the different microcontrollers.
The Arduino Mega is responsible for the robot movement, control, distance measurements, and the recognition of color underneath the robot. The movementation uses the distances read as the PID controller parameter. The color underneath the robot is identified from the reflectance index of each RGB LED color on the panel beneath the robot. When the robot identifies black or silver panels, a command is sent to the Raspberry Pi, and the new information is used in the mapping algorithm. Specifically, when a black panel is found, the Arduino Mega runs an exception to the rest of the code and moves the robot regardless of the command sent by Raspberry Pi. In more apprehensive moments, I even sing to calm myself down and also cheer my colleagues up, something that has become an habit within the team. And our team is united. That's what makes us a real team. All my colleagues, the teachers, everybody.
Being one of the robot controllers, the Raspberry Pi 3 has its role in the robot. We use 6 different Python 3 libraries, all developed to optimize the robot process, as it solves the challenges held in the modality. The first and perhaps the most important library is the mapping class, responsible for locating the robot inside the track, building a sort of map. We do not use any ready-made mapping algorithm, we have built our own. The class is also responsible for the map update and decision making according to the map being built and new parameters sent from the sensors connected to the Arduino. There is also a sensor class that controls the temperature sensors connected to the Raspberry Pi 3 through an I2C communication. The temperature reading from the 4 sensors allow us to get temperature fluctuations to locate the possible victims while the robot moves in the track. Besides all the code developed for the robot, there were other challenges, enhanced with the social isolation. We had to adapt so the project would not go astray, and so we could keep working on it. We all came up with different solutions for the whole of week 1 within the team, besides all the online meetings with weekly tasks that all members had. In my case, as the Raspberry Pi programmer, for example, because I don't have a Raspberry Pi at home and don't have access to the ones in the school, our solution was to install a virtual machine in my computer that emulates the Debian operating system, which is the Linux distribution most similar to the one in the Raspberry Pi itself. This was a great solution because the environment the virtual machine offers is extremely similar to the one we have in the Raspberry Pi, which was paramount in the tests we held without the Raspberry. Another solution we had as a team was in the organization and version control of the code by using GitHub, as we said before. However, we use it in the virtual machine and the Raspberry Pi interfaces with Gitcola, a graphical user interface for Git and terminal command lines, which was harder to use.
Last year, I couldn't officially participate in the competition because I was too young to travel without my parents. I had to help my college prior on the competition, otherwise I wouldn't able to do a thing when they were in the competition. In the beginning, I had some difficulties to understand the Arduino coding and I didn't have any experience with Python. Thus, I was in charge of making the printed circuit board for Raspberry Pi using the EasyEDA platform, which my professor taught me to use. During the weeks on the PCB development, I had to overcome myself so everything could be finished correctly and in time to deliver the project. However, as the pandemic spread and the social isolation began, we had to act quickly to avoid having lack of time to complete the project when things get back to normal. In the very same week the isolation began, our professors from different modalities created and organized a Discord server, making it possible for us to communicate, ask questions, and test the code together. The board project was finished some weeks ago and was handed to our professor on June 4th. Then he soldered the electronic pieces and components together. During the last days, I was in charge of finishing the code and the Arduino motor class. This class is responsible for making the motor turns around, resulting in the robot's locomotion. As I was having some questions along the way, I asked my colleagues and my professor for help. Now the code has been tested and it seems to be work correctly.
During the last 3 years, our team was being evolving and developing the project to improve our performance in the Latin American Robotics Competition editions. Bearing this in mind, we have several changes in the projects. It's visible that the size of the robots decreased considerably, from 21.6x 21.6 centimeters in the last years to 16.8x 18.5 centimeters. We are made this due to the necessity of having a high distance between the robot sides and the amazing ones, decrease the chance of physical shocks and interruptions during the task competition. Both in 2018 and 2019, we use leg sensors and reactors besides the EV3 brick itself. It runs the commands. However, because the results were different from expected, we decided to maintain the Lego-based structure and to remove its electronics.
We are working hard and testing our robot to make sure everything is in place and working properly for things get back to normal, so it can overcome the challenge in the modality and succeed in the tournament.